Unit 2, pages 17 through 22, Isotopes and Ions. Atoms and elements. Each of the atoms in the figure above is made up of the same elemental particles, protons, neutrons, and electrons. These subatomic particles are the building blocks of all atoms. All atoms of the same element have the same number of protons. All helium atoms must have 2 protons. The number of protons determines the element. So isotopes. Each element can have different types of atoms where the number of neutrons varies. These atoms have different masses and are called isotopes. So these are isotopes of helium. They all have the same atomic number, which means they have the same number of protons, but their mass numbers are different because they have different numbers of neutrons. This helium has 2 neutrons, this one has 3, this one has 4. Each unique isotope has a different number of neutrons. All isotopes of the same element have the same number of protons. All isotopes of helium must have 2 protons. Naturally occurring elements often contain several isotopes. The average mass of the element is calculated from the masses and relative abundance of its isotopes. So average mass is the sum of the abundance times the isotope mass. Recall also that the sum of abundance is approximately equal to 1.0 or 100%. In order to identify a specific isotope, a notation is used where the number of protons and neutrons are both specified. The atomic number is at the bottom left, which is the number of protons. The protons combined with the neutrons is equal to the mass number that's at the top left, and the elemental symbol is for He here for helium. Remember that protons and neutrons each have a mass of about 1 atomic mass unit. A helium atom with a mass number of 4 has 2 protons and 2 neutrons. Will have a mass of about 4 AMUs. The mass of electrons is so small in comparison that we just ignore their contribution to the mass of the atom. Example 2.6. How many protons, neutrons, and electrons does the isotope 35/17 chlorine have? This indicates that we have 17 protons, and since there is no value here, it must be neutral, which means it also has 17 electrons. These must be equal for this to be neutral. The 35 is 17 protons plus some number of neutrons to equal 35. And so if we subtract 35 and 17, we get that there must be 18 neutrons. And to determine the approximate mass, since the mass number is 35, then it has an approximate mass of 35 atomic mass units. Example 2.7, potassium has 2 naturally occurring isotopes, 39 potassium, which has a mass of 38.9637 AMUs. I'll put a little 39 up here in parentheses. And it has an abundance of 93.258%, which we'll change to a decimal, so 0.93258. We're going to add that to the other isotope of potassium, which has a mass of 41 AMU, and it has an exact mass of 40.9618 times an abundance of 0.06730, or 6.730%. So when we do this math, we get a value of 39.0935 atomic mass units as the average mass of these isotopes. Note that because this one is 93% abundant, then it makes sense for our answer to be closer to this value than it is to this value. For ions, the charge of an atom is determined by the balance between the number of electrons and the number of protons. So if you have a greater number of electrons than protons, then you have a negatively charged anion. If they're equal, you have a neutral charged atom, and if the protons are greater than electrons, you have a positively charged cation. Remember, a positive ion is a cation. Example 2.8, determine the symbol for the isotope that has 7 protons, 8 neutrons, and 10 electrons. So first of all, we put our protons here, and we look on the periodic table and find that that's the symbol for nitrogen. Then here, you're going to do the protons plus the neutrons, which is equal to 15. And then up here, there are 3 more electrons than there are protons, so we must have a -3 charge. And so the symbol will actually be 15/7 with an N, -3. Here's our note card for this section. You can pause the video to copy it. Isotopes have the same number of protons, which means they're the same element, but they have a varying number of neutrons, which is going to alter the mass number. The average mass is equal to the sum of the abundance times the isotope's mass. The symbol is going to have the mass number at the top left, which is protons plus neutrons, the atomic number at the bottom left, which is just number of protons, the symbol, and then at the top right corner, if there is a positive or negative charge for the ion, it would be in this location. If you have an anion, electrons are greater than protons, neutral atom, they are equal, and a positive cation means you have protons greater than electrons.